The focus, the vision of this project, which is in seed of discovery, is to characterize, identify, and mobilize useful genetic variation from gene bank to the wheat improvement program through pre-breeding efforts. So this effort is a teamwork, large number of the scientists, not only within CIMMYT, Mexican partners, other national partners, Indian partners, Pakistan partners, or so many other countries are contributing toward this effort. So as the target of this project is complementing the demand diversity with gene bank diversity through pre-breeding efforts. So first big question, which Prashant will explain in a minute, we have 150,000 accession in the gene bank. So it's not that our breeding program not used those lines before, but through this initiative or funding from Mexican government, we systematically mobilize those variation so that breeder can utilize, which you can see in the back. These are the final products. F8 is growing here. So breeder may like to see that going there. So to bring that variation, Prashant will explain what are the strategy used to funnel that variation into that stage. May Prashant?
Yeah, thank you, Sukhwinder. As you can see there, the land races, they are lodging on each other. So I will explain like what's the strategy, what's the key point, what's the key strategy to use to move those variation up to this variation. So we have around 39,000 land races, and most of them in gene bank, and most of them have been genetically characterized through genotyping by sequencing. And out of those land races, around 15,000 land races have been utilized. So the strategy was to genotype them through GBS and to phenotype them, sort of dirty phenotyping, so that we have a rough idea. And using genotyping and phenotyping information, we have made a core set using a different strategy. We published in Nature Scientific Report recently. We used genotype and phenotype variation simultaneously into a Gowers matrix, and then using those metrics we made classification and then made the core set. So the core set represented 90% rare allele variation of the complete set. In no crop, no core set has been formulated to capture this much rare allelic variation. So this was the one, and then there was another focus to identify the rare allelic variations separately. So that was possible because we did in-depth genetic characterization using large number of markers through GBS, not really a markers. So from GBS we get the markers, and then we are also in way to use the rare allele, the accessions with the rare alleles in Mexican land races and Iranian land races. So Mexican land races, Iranian land races plus fixed, they all together around 15,000, and then the core set of Mexican and Iranian is available in Gene Bank. If whosoever is interested, you can request to the CIMMYT Gene Bank through our website, and they are happy to provide. So this was the one, and we have already published papers about Mexican land race, and some more are in process. So this is all. Sukhwinder will explain how to use it to bring it up to this fancy level.
Okay, thank you very much, Prashant. I think I want to give you take-home message. Through this efforts, which is funded by Mexican government, I think to my knowledge, this is the first efforts in any government putting that much money on wheat and maize for around 50 million at that time, 4 to 5 years back. I think we really acknowledge this funding to pursue this work. Without this, it's not almost impossible. So first thing is we have done 100,000 wheat accession has been genotyped, 30,000 from Acarda and 70,000 from CIMMYT Gene Bank. And more than 80,000 accessions have phenotype. It's not individual efforts, it's whole team efforts. We have a lot of people from, that is the beauty of the CIMMYT. We have the infrastructures, we have expertise next door. We have most of the drought and heat phenotype is done by Matthews, and Pawan has done disease evaluation, Ivan has done phosphorus use, so many others. I cannot count all, but I think I just want to give the message. It's a big team efforts what we are doing. So then we have generated 1,500 pre-breeding germplasm till today by crossing 500 exotics. Total in the pipeline, more than 1500 exotics have been crossed, and they are in pipeline from F1 to F8. So this is the nutshell what I have mentioned as a take-home message. If somebody wants more detail, we can give it. And all this material which you see already genotype, now we are phenotyping. Now come to the pre-breeding component, which is the heart of this project. The idea is how these efforts bridge the gap between the breeders and the gene bank. So we use the straightforward approach, not high science or something. We consider that if we have to bring the land races variability into the elite material, we take the best 20 lines from Rabi program, well characterized, high yielding, disease APR, so many things are there. So then we cross with the land races or exotics in such a way which is unique and complementary to the breeding program. Because in F2s, we have in F2s to F5, we evaluated material under drought and heat conditions. So whereas in our breeding program, they evaluated under drought and heat after they fixed the material. So that way we give more opportunity to look more drought and heat stress allelic variation from the land races to our elite material. So in this case, in the background, this side is the F8, these are the second year final yield trial, advanced yield trial. These are the big trial, 3 replications. On the other side, you can show these are the F1, first primary yield trial. Then the other at the corner, those are the land races. You can see how we mobilize those big, tall land races to bring this. I hope some of you breeders may like to use these material in their breeding program for some of the trait of their interest instead of using those land races. So we have generated this from, as I mentioned, that we started F2, TC1 F2 is about 400,000 F2 individuals in the first breeding cycles. Then when we go to the F2, we have selected around 8,000 F2, F5 individual plants. Then we grow in Elbatan and Taluka, then look their agronomic performance, and if some are really susceptible to diseases, we reject those individuals. But you can see still we can maintain a lot of variation in advanced material. So we maintain the diversity, but they are also, we are looking some of the material which we get the feedback from different countries where this material is grown in Pakistan, India, Iran, and so many others. They already give the feedback. They have value not only for drought and the heat, but some other trait of their interest. They are looking for those. So this material we have generated continuously under drought and heat, but these material is available to anyone who need it, and they are already genotyped. That information is already available. So this, because the now next question we have to address, which is asked by our leaders, what are the contribution of the exotics into our elite background? So we may have already all the information. So those things we are working to putting the multi-location yield trials and other phenotypic data. Once we have the information and the data, then we compare what is not, what are different haplotype. And Deepmala is also working closely with us, and she is more doing genetic analysis with the other team, and we are looking what are different haplotype which is not present in the elite but present in our exotics and seen in our pre-breeding materials. So then we look if those which is not present in the elite coming from exotics, they have any association with useful trait for our wheat improvement. So I think with these words I keep the discussion open with your questions, and happy to share the information freely. This material is already sharing, and we happy to share with any of you if you like to see value for your program. Thank you very much.